Okay, everyone, we'll get started. The last talk before lunch is Oliver Nagy, who's going to be talking to us about how to create and watch Kubernetes resources with Python. Can we get a round of applause, please?
No? Okay, that's better. So for some reason, I decided that this year, I'm going to add a logo to my talk. In retrospect, I'm not entirely sure why I did that, because ultimately it doesn't add much. Naturally, that's what I spend most of my time doing in the presentation. So you have to admire the logo more than the presentation. I was pretty happy about it at first, and then yesterday I went to a talk by Jenny Rosenbaum, and she explained how you can actually create them with machine learning. And I thought, crap. So all the time that I spent on this beautiful logo here, I could have saved myself a lot of effort. So after her talk, I got home inspired, and I was faced, should I fix the bug that I know is in the repository for the demo files, or shall I create a better logo? So I did a better logo, of course. And the thing that she had that had really excited me was you can take just a picture of something, which I can do, and you can take a picture of something else, and then somehow this deep dream network creates something that looks like this, like a Rembrandtified version of your input. So I thought, that's great. I can take my logo then, and this PyCon logo, because how hard can it be, right? And so I put it in, pressed enter, and hope for my amazing art, and that's what I got. So I know she was very excited, because apparently those networks, they can create colors that were not in any of the input images. And I really kind of wish it didn't. Because I was a bit underwhelmed. So the takeaway that I got from that one is that if the input image is already amazing, I mean, it's this condensed raw talent of art, right? So if it is that good, then the network can't do anything better to it. The other thing is, machine learning is simply overrated. So don't waste your time doing machine learning, do Kubernetes instead. So which is obviously why you're here in this talk. So this talk is a bit different because it is the if I can do it, you can do it talk. I'm going to talk to Kubernetes, do a couple of things with it, and I'm going to live code everything, believe it or not, which means I'm also going to run or use a live cluster in Google Kubernetes Engine in this case, which means we will need an internet connection. So in the next 20 minutes, if we have the internet connection, I'm going to show you how you can do a couple of simple things like listing, creating, and deleting namespaces. And you're going to be disappointed by how easy the one actually is, because it is just a normal get, post, and delete request. Then afterwards, I do something slightly more sophisticated. I'm going to subscribe to various resources on Kubernetes so you can actually watch them as they change. Very useful if you're looking after a cluster, because it allows you to easily keep a tab on what's changing. So a pod dies or a pod got evicted, you immediately get a notification. Lastly, I'm going to write, believe it or not, a small ingress controller. And what that ingress controller does is it adds a feature that is missing from the Google ingress controller. Is anybody here running a Django stack on Google Kubernetes Engine by any chance? No one. Oh, wow. Okay, but if you were, so you if you were, you would be unhappy with the status quo because you cannot attach a timeout annotation to your ingress, which means all your load balancers have a 30-second timeout, which is not long enough to proxy WebSockets. And I'm going to fix it, even though nobody of you will obviously going to care, I just realized. But I'm going to fix that anyway in a completely non-invasive way. So let's get started. Oh my gosh. One thing, by the way, before I get started, all the files, all the demos that I'm creating are available in this GitHub repository if you want to follow on in your own time. So we are going to need the OS library, we will see in a second, and I'm going to need this utils library, which is in this repository. It's a completely flat library, only 160 lines of code to save me some boilerplate. Nothing much going on. And the first thing we need is authentication credentials for Kubernetes, which are in your kubeconfig file. And I save myself some typing here by load autoconfig. So this conf is simply a named tuple, has 4 entries. 2 of them are related to the SSL certificates, so they can talk to your server. One is the server address itself, and the last one is the bearer token. The second thing I need in order to talk to Kubernetes is a client. I'm going to use the requests library in this case. Jesus. So this is another convenience wrapper simply because I need to make it aware of those SSL things that I just mentioned that is in this conf, and I need to add an authorization header that contains the bearer token. I don't want to show you the bearer token. That's why I put that away in this setup routine here. But all it is a normal request session object. There's nothing special about it. And believe it or not, that is already all you need in order to get cracking on Kubernetes. So let's get some namespaces, for instance. That's some API, v1, namespaces. If they worked, it will come back with a 200. And you will be presented with a namespace manifest, or a namespace list manifest. So all you got to do is now, everything that Kubernetes returns is JSON, obviously. So all you got to do is iterate over this thingy here. It has these field items, and each of these items is a namespace manifest. It has, like every manifest, it has metadata, and we're going to use that one. To print out the names of the namespaces. So let's see if that actually worked. And voila, these are all the namespaces on your Kubernetes cluster. And just to prove to you, there's really nothing. They're big enough to read, by the way. I can make it bigger. Okay. So, not surprising, same namespaces, obviously. So you have already reinvented one part of the kube control command. So similarly, if you want to, this is for listing namespaces. Similarly, if you want to create and delete namespaces, it works pretty much the same. So if I create namespace, it's going to be a post request, who would have thought? And I need to pass along a namespace manifest. I'll show you that in a second. Just going to load it here. So that's the namespace manifest, just the standard stuff that you see when you look up the documentation for kube control. In this case, it's going to be obviously of kind namespace, and we're going to create a namespace called PyCon. And similarly, if you want to delete a namespace, it's really not hard to guess. All you got to do is a delete request, and then you specify the namespace that you would like to delete. So the only change is that if the namespace was created, it's a 201. If the namespace already existed, it's a 409. Both of them are acceptable right now. We'll also need a YAML parser here. And it has now created and deleted a namespace, but so I say, right? Can you prove that to you that this really did happen? So these are just the 4 default namespaces that we have. When I run my program, you will see it will immediately add the PyCon namespace, and afterwards immediately schedule it for a deletion again. And that, believe it or not, is really all you need to know in order to work with Kubernetes. It always comes down to, obviously, knowing your endpoint, API with our namespaces in that case, and then doing a get in order, if you want to list a resource, doing a post if you want to create it. You can do a patch. I'm not going to show that. To patch it, delete it, and it's really that simple. So if you were hoping for anything more sophisticated, that's about as bad as it gets. Now, namespaces in and of itself not so exciting. Obviously, you can do that with every resource that Kubernetes has, and you don't really have to change much in terms of your code. So these are all the pods that are running on this cluster at the moment. We can make this here look a bit more informative. We can, for instance, print out the namespace. And now you know which saving would be good. So, and now you know that I have in my default namespace, I have a sleeper pod, in my Hello World namespace. I come to that one later. There are 2 pods running, and Cube System is just a normal system namespace with their own pods. And that is it in order to get to ports. And you get to other resources in the exact same way. You only have to figure out the URL here. So if you want to see deployments, you would think they might be here, but they're not, because deployments are not part of the core API. So you have to go look at the Kubernetes API, and then you find there are APIs, extensions, and for this version of the cluster, they are still in beta. And you get all your deployments in the exact same way. So it's really rather boring at the end of the day. So I'm not going to bore you with listing more resources here. Another thing you can do that I mentioned before is subscribing to certain endpoints so that you get notified whenever something changes. So that is, I find it very useful when you're looking after clusters, because you can subscribe to the pods endpoint, for instance. And then every time something changes about your pod, so a pod gets deployed or gets evicted or it gets modified, you immediately get a notification. You can couple it with a Slack notification if you want, or send yourself an email or a tweet about it if you feel like it. And it's a really good way to keep a tab on your cluster. So maybe not on Google scale, but for a startup scale, that's actually a very nice shortcut initially, just to keep a tab on all the things that your coworkers are doing. So I'm going to show that with the ports. All you need is which is true. Again, it's just straight from the API. And because this is now a streaming response, we need to tell our request client that this is a streaming response, otherwise it will block forever. Which also means that this one here, that's also purely from the requests library. Going to iterate over our lines, which comes back as binary blobs. Bear with me for a second here. So what you get is a type, which is just a string, and it simply says edit, modified, or deleted. Those are the 3 options, and you get the object, which is again the normal manifest file that we received before. So I can now do the same thing again and run this program. Yes, almost, isn't it? So here it is, the same information as before, because every time you watch an endpoint, you first get a list of all the resources that are there, just as if you had it listed normally, but you're also now getting a tag of what happened. So initially, Kubernetes will tell you every resource that was already there has the edit tag, just the way it works. And now you notice the program is still running. So if I now kill my sleeper pod here, for instance, then you will see I get a notification it was modified. That's when it got scheduled for deletion. Since it was in a deployment, Kubernetes immediately spun up a new pod. That's this one here. And this pod goes through the various startup phases. And eventually, the other pod will be expunged, and you will see a deleted here. So that's just a very convenient way of keeping a tab on all your pods in your cluster. Break that here. So you can tailor it down. I'm not really going to show it in detail, but if you're just interested in pods in a certain namespace, again, the API is very clean. You just defaults, I don't even know what it's called now. Just make it like this one, and then you only get the pods in one namespace. So that's for the watching part. Now, the last thing I wanted to show that I thought was some people would be interested in, but nobody's using it on Google Cloud, so obviously maybe not that interesting. But the last thing is building a small ingress controller for Google Cloud. Or it's not a replacement, it's simply an extension. Because one thing that, as I mentioned already, the one thing that the Google Ingress Controller doesn't do is it doesn't have a timeout annotation. So you can put one in, but it will ignore it. And that's been a long-standing issue. There's been a GitHub ticket filed about 18 months ago, and it's a very long thread. And for some reason or another that I don't fully understand myself, it just hasn't made it into their ingress controller. So you can hack the ingress controller and replace it. That's one option, or you can just use a few lines of Python and edit yourself without touching the original ingress controller. So the way that works is, the way every ingress controller works is you're watching the ingress URL endpoint, just like we have watched ports here. And every time the ingress changes, you're going to read the annotation, you extract the backends, and you extract this timeout value that you would like to have. And then you use the normal Google Cloud API and set the timeout value for those backends. And voila, you have a timeout annotation, or you can support arbitrary timeouts with Google Cloud ingresses as well. So you need APIs. So down here we need to get the backends. That will be in so, and similarly, the timeout that we can then specify will be, I call this one here the PyCon demo timeout. You can really name it whatever you want. I was just pretty certain this name would not clash. And then here, call the Google API to update the timeout. So this part, I'm not going to live. Something's up with my keyboard. This part, I'm not going to live code, but you find the example here in the repository. This is the full ingress controller, which I have already deployed. So I'm going to prove to you it actually works. This is precisely what we had before, creating the client. This is watching the ingress endpoint. This is iterating over the events that come in. We're going to ignore everything that's not a modified event. You can ask me afterwards why we don't worry about edit. This is extracting the backends that the ingress controller has provisioned for this ingress. This is unpacking the timeout value that we will add and doing some error checking. And then down here, this is the one core. This is the one function that I didn't write explicitly. That's just a patch request via the Google Cloud API to set the timeout of your ingresses to whatever you would like. So, and this is how that works. So this is how it looks. Currently, the timeout is 200 seconds. And I can now go and edit that ingress in my Hello World namespace. And set it, I don't know, to 50. Then, we should have shown you that one here as well. Yeah, okay, we're already too late. Doesn't matter. Point is, this one here will now hopefully have changed to 50 seconds. It has not, of course. It's the first time it has not worked. It was supposed to change. Okay, this is now really indeed a bit embarrassing. So maybe something got stale with the connection. Let's try this one more time. Yeah, here it goes. So now it has picked up so it was listening to this ingress endpoint, and now it has picked up the change. It will read the annotation and extract the backend from that one, which is this thing here. and the timeout value now 60, and the same for the second backend. So in Google Cloud, there are always two backends, one for the forward, one for the actual pod, but it's a technical detail. And if I now go here and refresh that one, it has changed the timeout to 60 seconds. And I didn't have to hack the original ingress controller. It is completely complementary to the one that Google already has. If one day they do add the timeout, all you have to do is kill that pod, and you're good to go. And that's how you can fix a problem with a few lines of Python code that hasn't been fixed in 18 months for reasons I don't fully understand. OK, and that is the end of my talk. Yeah, so I think we have time for
We've got time for questions.
Maybe.
Has anyone got one?
Why not use the Python client for Kubernetes? Because in particular for a watch, one of the things you're not handling is if you lose the connection, when you reconnect, you're going to get the whole object stream again. Whereas the Kubernetes client will automatically reconnect for you and will only give you the results from the resource version you're up to.
Yeah, so the reason why I don't use the official Kubernetes Python client is because I don't like it. So that's the simple reason. And the reason why I don't like it is because it goes to great lengths to hide all the things from you that you are interested in. So the official Kubernetes Python client is just a Swagger wrapper around every possible API there is. So if you install that library, you're getting a couple of dependencies, and it installs, believe it or not, around 220,000 lines of code. And all it does, it has one wrapper for each of these. And you do not actually have access to the underlying connection. You do not know, you don't even know which server you're talking to. You do not know which headers were sent. All of those things I find is very useful for debugging, and I didn't have that one. In terms of the particular example I mentioned with the watch, all it does is it takes the last resource element or the last resource version and automatically reconnects and passes that on as a resource version parameter. So it's literally a 3 or 4 line extension, and then you can have the exact same behavior, but you stay in control of your connection. So you know your connection parameters, rather having some proxy library doing something under the hood that you do not fully understand. So that's why I use that one.
You may want to have a look at the OpenShift client. Like, it's still Kubernetes, but it has a dynamic client. So instead of a hugely generated Swagger API one, it's 500 lines of Python code, dynamically queries all the resource types and generates on the fly. It's a lot simpler and easily. You don't have to do all the different class types.
OK, I didn't know about that one. Yeah, I might use that one. But as I said, I wanted this one to be from first principles, just to show you there's really no secrets that are baked into those libraries. It's not difficult to talk to Kubernetes directly with the normal REST client.
Any more questions? OK, well, we'll be having lunch. Can we get a round of applause for Oliver? And we have, of course, the lovely mug for you.
Thank you very much.